Next, let's tackle bundle branch blocks. When you're looking at an EKG, the first tip-off that there might be a bundle branch block is going to be a QRS duration that's greater than 120 milliseconds. If you see that, the next thing you want to do is look at your V1 and V6 leads. These leads give you two opposing views of the heart. V1 gives you a view from the right, and V6 gives you a view from the left. Let's start off by looking at a normal V1 and V6. The first thing you see after the depolarization of the atria, so starting from the AV node, is going to be depolarization of the septum. This will move towards the right V1 electrode and away from the V6 electrode. So you will get a positive deflection in V1 and a negative in V6. Afterwards, you have depolarization of the ventricles occurring simultaneously. Since the left ventricle is greater and larger, you'll have a primarily positive deflection in V6, which is looking at it from the left, and primarily negative in V1. And then afterwards, once you have complete depolarization, you have a return to baseline. So here we see what we would expect a normal V1 and V6 to look like. Now let's consider a right bundle branch block. In a right bundle branch block, you still have normal depolarization of the septum, since that comes via the left bundle. So we have the same positive deflection in V1 and negative in V6 for septal depolarization. Afterwards, we still have our normal depolarization of the left ventricle, proceeding via the left bundle branch, and this happens pretty quickly. So we have our same negative deflection in V1 and positive in V6. Now, the right ventricle is going to depolarize slowly, going from left to right. This happens in a delayed fashion since it's not occurring via the fast bundles. So you get a later positive deflection V1, since now we're depolarizing the right ventricle in this direction, and a negative in V6, since it's going away from our V6 electrode. And then we have our return to baseline after both ventricles are depolarized. Moving on, let's look at the left bundle branch block. In a left bundle branch block, we no longer have our normal septal depolarization. Instead, we will have slow depolarization of the septum going from the right bundle over to the left. So since we're moving this way, we're going to have a negative deflection in V1 and a positive in V6. After this, we have our normal depolarization of the right ventricle, which occurs here. So we have a positive deflection in V1 for the depolarization of this area here, and a negative in V6, since the depolarization of the right ventricle is moving away from the V6 electrode. Afterwards, we have our delayed depolarization of the left ventricle that proceeds from here towards our V6 electrode, causing a positive deflection in V6 and consequently a negative one in V1. And then afterwards, once again, we have both ventricles depolarized and we get our return to baseline. Once again, it's really important to highlight that these patterns are significant for the bundle branch blocks only when you have a QRS duration that's greater than 120 milliseconds. And here I'm going to give you two memory hooks to try and remember how right bundle branch block and left bundle branch block look on an EKG. The first one is you remember the name William Morrow. What this gives you is the first letter here is going to be the pattern you expect to see in V1. The last two letters are the ones you expect to see in V6. And then the L and the R in the middle tell you whether it's a left bundle branch or a right bundle branch block. So for example, for the left bundle branch block, we expect to see a W pattern in V1 and an M pattern in V6. Similarly, in a right bundle branch block, we expect to see an M pattern in V1 and a W pattern in V6. The second memory hook I've come across is, let's pretend you have two cars that are driving left in your V1 lead, and they come to the QRS complex. Which way is the car going to turn coming from this direction? In a right bundle branch block, this car is going to signal and turn right to go up here, giving you a right bundle branch block, while in a left bundle branch block, the car will have to turn left to continue following the road. And that is another way to try and remember the bundle branch blocks. So let's look at two real-world examples of bundle branch block. Here's our first one. And the first thing we know is that we have a QRS duration that's greater than 120 milliseconds. Next, we can use one of our memory hooks to figure out what type of bundle branch block we're dealing with. We can use our William-Morrow and see that we have a kind of a W shape in V1 and then a very clear M shape in V6, which suggests a left bundle branch block. We can also take our car here, and if we have our T wave here and we're driving towards a QRS complex, we're going to have to turn left. So in this case, this is a left bundle branch block. Now the left bundle branch block is very important because whenever you have a new one on an EKG, it can be suggestive of an ongoing myocardial infarction. So you always want to compare to previous EKGs to see if the bundle branch block is new or old. And so obviously this one's going to be a right bundle branch block, but let's still work through it. Using William-Morrow, we see our M in V1 and a W in V6, suggesting a right bundle branch block. Or we can take our car, put it in V1 going left towards the QRS complex, and we have to make a right turn, so we're dealing with a right bundle branch block.